Welcome to Completing the Square. This should be a fairly short video, mostly because the 5 steps are the same. This was not technically required by Oklahoma standards, but basically, again, we're looking for these two solutions. And if factoring doesn't work and you just don't like the quadratic formula, maybe this one's for you. And I did have a couple students when I taught this go, I like this one better. Then go for it. It's not my favorite, but we'll get there. Here are the 5 steps. It doesn't really make sense now, so pause the video, write it down, we'll just keep going. All right, so step 1, move the constant, and I left a little blank right here. Step 2 is find b over 2 squared. Well, my b value is 5, so 5 over 2 squared, put that in the calculator, 25 over 4. Step 3 says add that to both sides. We're always going to add because whenever you square whatever this is, it's going to be positive, so we're going to add to both sides. Factor and simplify. Well, this factors to this. How did I get this? Well, this, b over 2, and this, that's what I said back here, your factor is going to be the b over 2. So b over 2, without it being squared, is going to be your factor. We are forcing this to become a perfect square. So we can square root both sides, and remember that's like square root in the top, square root at the bottom. We get this. Move it over, and we get -5 halves plus or minus 1/2. But since we have actual numbers, when we actually add them, we get -2 because -5 plus 1 is -4 over 2. -5 minus 1 is -6 over 2. We get our chance. Yes, this could have been factored, and it would have been really stupid, but it would have been 5 halves times 5 halves, because 5 times 5 is 25, 2 times 2 is 4, and then 2.5 and 2.5 add to 5. But what we're trying to do is we are forcing this, and this is just a separate example. We're trying to force this part to become this by using b over 2. So b over 2 gave us 3 squared. 3 squared equals 9. We're going to add 9 both sides. Well, now if I factor this, 9 on top, 6 on bottom is 3 and 3. We are forcing that any other number up here, we wouldn't get 3 and 3. But because we kind of get to choose this number, we chose 9, so they would be 3 and 3, and they would be the same. That way I could write it like this. And once I write it like this, kind of like back here, I can just square root both sides and keep going, and my square is gone. That's how we get rid of the square with completing the square. So back here, they're like, well, why did we choose 25 over 4? Where did that even come from? Well, if we choose any other number, we won't get a perfect square. But because we chose this right here, we forced it to become a perfect square. Now, kind of, I don't want to say it kind of messes up the other side, but it makes the other side sometimes not amazing. But over here, we'd have equals 9, and so now I can square root both sides and then move stuff over and do it that way. So step 1, move the constant. Step 2, b over 2 squared, 9 over 4. Step 3, add it both sides. And again, if I'm going too fast, press pause, then go back, write everything down, then go back. Step 4, factor and simplify. Well, I don't have to factor because it's going to be x plus this b over 2. So x plus 3 halves squared. Remember, we got our perfect square. Equals square root of 29 over 4. Well, this is where it kind of gets messy. The bottom's always going to simplify because we squared it, and then we're going to square root it. So it's just going to happen. So the bottom square roots, the top does not. When I square root here, it just gets rid of that. So all I have to do is move this over. We're going to take this guy and we're going to shove it in front. -3 halves plus or minus square root 29 over 2. Well, because both of these are both over 2, a lot of times we could just shove it all together. And this is kind of what we're used to seeing, x equals -b plus or minus square root of b all over today. That's what we would have gotten. Yeah, here's another example. Move the constant, b over 2. B was actually a nice, pretty number, so we could have factored this, but we don't have to. This -3 and that -3 is the same. Square root, move over. I think if you would have done it quadratic formula-wise, you would have gotten this here in green, and you would have gone, oh, 6, 2, and 2 can all be divided. So we move it like that. And for completing the square, a must equal 1. Yeah, the biggest thing, a has to equal 1. So this is why I don't like completing the square, because you may end up with some crazy fractions. So you have fraction over 2 squared. This ends up being this 7 over 4, actually. But everything works the same. And we get down here and square root, and I mean, everything's the same. Same thing here. We divide by -5 and get this to be a +1, and then it just ends up being the same thing. So you can write these down, but yeah, just make sure with completing the square your a value is 1 before you move the constant, find b over 2 squared, and just remember your b over 2 is your whole b value divided by 2. Make sure you calculate that before you square it, because you're going to need that down here. But that was basically it for this.